Hi everyone, this is Professor Oaks, and this video is about inverse trigonometric functions. Alright, so first let's talk about the definitions of the inverse trigonometric functions. So the inverse sine, or the arc sine function, is denoted by sine inverse of x, so you can write the arc sine of x instead. For the inverse sine, right, is defined by sine inverse of x equals y if and only if. So this IFF notation means if and only if x is equal to the sine of y and y is between negative pi over 2 and pi over 2 inclusive. So this is the closed interval from negative pi over 2 to pi over 2. Alright, so now the inverse cosine or arc cosine function is defined by cosine inverse of x, or arc cosine of x is defined by cosine inverse of x equals y if and only if x is equal to cosine of y and y is between 0 and pi inclusive. Alright, so now let's look at another one here. So the inverse tangent or arctangent function is denoted by tangent inverse of x, or arctangent is defined by tangent inverse of x equals y if and only if x is equal to tangent of y and y is between negative pi over 2 and pi over 2. So that's the open interval from negative pi over 2 to pi over 2. The inverse cotangent or arc cotangent function is denoted by cotangent inverse of x, or arc cotangent of x is defined by cotangent inverse of x equals y if and only if x is cotangent of y and y is between 0 and pi. So that is the open interval from 0 to pi. Alright, now here is an important note for those of you who do not have very good calculators or no calculators at all, and you might need to calculate this by hand. Then the cotangent inverse of x is pi over 2 minus the tangent inverse of x. So that might help you enter the arc cotangent function in the calculator. Alright, the inverse secant or arc secant function is denoted by secant inverse of x, or arc secant of x is defined by secant inverse of x equals y if and only if y does not equal pi over 2 and let's see, y is in the interval 0 to pi, and again x will be secant of y. Alright, so another way to write this statement here is y is just in the interval from 0 to pi over 2 and pi over 2 to pi, so that we don't have to write the restriction of y does not equal pi over 2 separately. We can write it like this. And if you want to know how you might enter this in the calculator, it's secant inverse of x is cosine inverse of 1 over x. Alright, so there you go. That's another tip for you right there. The inverse cosecant or arc cosecant function is denoted by cosecant inverse of x, or arc cosecant of x is defined by cosecant inverse of x equals y if and only if x is equal to the cosecant of y and y is not equal to 0, and y is in the interval from negative pi over 2 to pi over 2 inclusive here, so that closed interval. But again, a different way to write this statement here is just y is in the interval from negative pi over 2 to 0 and 0 to pi over 2, so that we don't have to write these two statements separately. And then in the calculator, you could calculate the arc cosecant of x is sine inverse of 1 over x. All right, so try to remember this all for the rest of your life. So now let's find the value of each of these expressions. I'm going to use a TI-84 here. You can use whatever you would like or calculate all of these mentally. So the first thing to notice is that these are all in radians and not degrees. All right, so your calculator should be in radian mode. So I'm going to check that myself right now. All right, so mode, and I see that the calculator is indeed in radian mode. All right, so now I'm going to go to secant sine to get sine inverse, negative 0.2357, and I end up with a, now remember that this is just going to be a rounded off value, so approximately negative 0.237938789. So now the arc cosine, secant cosine of negative 0.2357 will be approximately 1.808735126. Now the arc tangent, secant tangent of negative 0.2357 will be negative 0.23147522225. All right, so hopefully you enjoyed that. Now let's do another one here. So let me find my example right here. All right, so the arc secant of negative square root of 2. Now remember that I said that this would be cosine inverse of 1 over negative square root of 2. So this is one where you can calculate this mentally actually, but if I wanted to do this in the calculator, I go secant cosine negative 1 over the square root of 2, and I get about 2.356194449, or else, again, I could actually just realize that this is an exact value of 3 pi over 4. All right, and 3 pi over 4, same value. All right, so now let's try another one, cotangent inverse of negative 1. So this will be pi over 2 minus tangent inverse of negative 1. So this will be let's see, pi secant pi divided by 2. Oh no. All right, minus secant tangent to get tangent inverse of negative 1, and that will be equal to approximately 2.356194449. Well, then we see it's the same exact answers right above, but mentally this will be pi over 2 minus the tangent inverse of -1, which is negative pi over 4, which is 3 pi over 4. All right, so now the arc cosecant of 2, this is sine inverse of 1 over 2. So let's do this. So we have secant sine to get sine inverse of 1 over 2. So that is approximately 0.5235987756. And if I did this mentally, the arc sine of 1 over 2 or sine inverse of 1 over 2 will be pi over 6. And you can check that pi over 6 is the same result here. All right, so let's evaluate each expression without using a calculator. So this actually should be sine inverse, not just sine to the first power. Sine inverse of a half. Well, we just had that up here, but if I wanted to do this without a calculator, here's more precisely what I would do. Another way of writing this is if this is, say, y, then that means sine of y is equal to a half, and sine is opposite over hypotenuse. So here we go. The opposite side from this angle y here would be 1, the hypotenuse 2, so it's a 1, 2 square root of 3 triangle. So we know that this is pi over 6. All right. So now, let's say this is equal to y here. Same thing. All right. So we know that the cosine of y then would be -1 over the root 2. But I know that the, here we go. The domain of the arc cosine is between 0 and pi. So we have to be between 0 and pi. And in quadrant 1 here, the cosine of an angle theta has to be greater than 0. In quadrant 2, the cosine of an angle theta is less than 0. So I know this is in quadrant 2 because it's negative. So here's my angle here. All right, and here's my reference angle, y. So the opposite side from here is over here, adjacent here, and hypotenuse here. Cosine is adjacent over hypotenuse, so 1 and square root of 2. So this is a 1 square root of 2, 3 triangle, or that means that this must be pi, sorry, 1 square root of 2. And what I said made no sense here. So there's actually something, just so you know, that as I mentioned, I think in one of my earlier videos, I'm working from my home right now, just like some of you are at the moment, and things are flying around in the air. So I apologize for that. So 1 square root of 2. So I know that this ends up being pi over 4, which means this angle is 3 pi over 4. So 3 pi over 4. Now, the tangent inverse of -√3 over 3. So remember, the domain of the inverse tangent or the arc tangent is between -pi over 2 and pi over 2. So here's -pi over 2 to pi over 2. In quadrant 1, the tangent theta is positive, And in quadrant 4, the tangent of theta is negative. Since this is negative, I know we're in quadrant 4. So the tangent of the y here is negative root 3 over 3. All right, so here we go. And tangent is, well, that's opposite over adjacent. So the opposite side here from this angle will be the square root of 3. The adjacent side will be 3. So then what do I know? I know that this right here, the hypotenuse, by the way, if you don't go ahead and figure out what it is, that's okay. Because if you already know what the angle is, that's fine as well. But let's see here. So opposite and adjacent. Now, by the way, as I mentioned this, let's see. This will be, where is it? It should be 2 root 3. All right, so just try to remember this for the rest of your life here. And this means that this is going to be negative pi over 6. All right, negative pi over 6. Now, by the way, just so that you're aware, it might actually be easier in some cases to go ahead and rationalize the numerator here so that you get square root of 3 over square root of 3, so that's negative 3 over 3 root 3, which is negative 1 over root 3, and then you would be drawing the triangle to look like this. All right, so let's see, we have 1 square root of 3 and then 2 over here. So then you can see maybe more clearly how I did this mentally. I knew this was 1, 2 square root of 3 because this is just all the lengths of this triangle multiplied by the square root of 3. So square root of 3 times square root of 3 is 3. Square root of 3 times square root of 3 is 3. And then 1 times square root of 3 is square root of 3. And 2 times square root of 3 is 2 square root of 3. All right. So now the secant of 2 times sine inverse of 1 over 8. So let's let the theta be sine inverse of 1 over 8. And so sine of theta is 1 over 8. So then this is equal to secant of 2 theta, which is 1 over cosine of 2 theta. Now use an identity. Cosine of 2 theta is 1 minus 2 sine squared of theta. So I have 1 over 1 minus 2 sine squared of theta. And I know sine of theta is 1 over 8. So I have 1 over 1 minus 2 times 1 over 8 squared, which is equal to 1 over 1 minus 2 times 1 over 64, which I'll do this all out mentally at this point. So 1 over 1 minus 1 over 32, which is 1 over, 1 minus 1 over 32 is 31 over 32, and then the reciprocal of 31 over 32 is 32 over 31. So this is 32 over 31. What a time to be alive. All right, so now let's do another example here. Show that the cosine of the sine inverse of x plus the sine inverse of y is equal to the square root of 1 minus x squared minus y squared plus x squared times y squared minus xy, for x is between -1 and 1 inclusive, and y is between -1 and 1 inclusive is an identity. So let's call this sine inverse of xa and the sine inverse of y and b. Then you should know the identity cosine of a plus b is cosine of a cosine of b minus sine of a sine of b. Then we have cosine of a, which is sine inverse of x, times cosine of b, which was sine inverse of y, minus sine of a, which is sine inverse of x, plus sine of b, which is sine inverse of y. Then, let's see, this sine of sine inverse of x, that will just be x, and sine of sine inverse of y will just be y. So we have x, y here. Actually, actually, I'm not sure why I wrote a plus here that wasn't actually in the identity here. So that should just be times, and this should be times. All right, so now we need to figure out what the cosine of sine inverse of x is equal to. So let's look at this here. All right, so let's draw a triangle to maybe help us out here. So I know, say, that the sine of sine inverse of a letter t is t, but if I want to know the cosine of sine inverse of t, then think about this, all right? Cosine of sine inverse of t over 1. And then, I want to actually write the, when I said t over 1, I meant t over 1. All right, t over 1. Now, we just talked about the inverse sine on the last or page of examples here. So the sine is opposite over hypotenuse. So here is my angle, and the opposite is side from theta is t, and the hypotenuse is 1. So this length right here is 1 minus t squared under the square root. So you can use the Pythagorean theorem to get that if you would like, or you can just memorize everything. And then, cosine is adjacent over hypotenuse. So the adjacent side is the square root of 1 minus t squared. The hypotenuse is 1, so this is the square root of 1 minus t squared. So this right here is square root of 1 minus x squared, and this right here is square root of 1 minus y squared. I'll multiply these together here to get, well, what am I going to get? The square root of 1 minus y squared minus x squared plus x squared y squared minus xy. And that is correct. Actually, you know what? Our work is correct, but this the problem was not correct on the page. So I will be quite honest with you that I'm not sure why that square root extended over the xy in the problem that was typed out here, but yes, this is an identity. What a time to be alive. All right, so now let's simplify the expression cosine of 2 times secant inverse of x for the absolute value of x is greater than or equal to 1. So we're going to, well, let's let theta be secant inverse of x, and then secant of theta is x, and 1 over cosine of theta will be x, or cosine of theta will be 1 over x. So let's look at our identity. Cosine of 2 theta. Remember to memorize this identity here. This is 1 minus 2 sine squared theta. And sine squared theta then is 1 minus cosine squared theta. So we have 1 minus 2 times 1 minus cosine squared theta. And we'll distribute the negative 2 here to get 1 minus 2 plus 2 cosine squared theta. Combine like terms to get negative 1 plus 2 cosine squared theta. Then I'll substitute the cosine of theta equals 1 over x here. So we have negative 1 plus 2 times 1 over x squared. And then that becomes negative 1 plus 2 times 1 over x squared, or I'll multiply to get just negative 1 plus 2 over x squared. If you want to find a common denominator, that's fine. If that's how you want to live your life, that's fine. What a time to be alive. I hope that you enjoyed this video on inverse trigonometric functions and that you're already looking forward to the next video. Thank you and have a great day.